We have already learned how to put several different groups on benzene, including halogens, nitrogen, sulfur, and even carbon groups. But if we want to think about synthesis, which means we're thinking about how to convert simple starting materials into more complex products, we want to have as many different reactions in our toolbox as possible to get whatever we want on the ring. So what we're going to do next is look at some different chemical modifications to benzene substituents. So what that means is if we use one of those electrophilic aromatic substitution reactions to get something on the ring, like we have here, this would have been made from a Friedel-Crafts acylation. So once we have something on the ring, what can we do to transform that something into something else? The first reaction we're going to look at is a reduction reaction. And sometimes when we're being generic and we talk about reduction, you'll just see a hydrogen written in brackets, and that is representative of a reduction. So if we take an aryl ketone, and an aryl ketone is when you have a ketone on the carbon next to the aromatic ring, we can reduce this. There's two different sets of conditions that you can use. We can use this zinc mercury amalgam and hydrochloric acid, or we can use this H2N NH2. This molecule is called hydrazine, and hydroxide. The difference is acidic conditions versus basic conditions. But it doesn't matter which reaction condition we use, we actually end up with the same product. So what happens here is this carbon that bears the carbonyl, right here, that carbonyl gets reduced completely off, and that carbon ends up with 2 hydrogen on it. So here would be the product. We have a 4-carbon chain, in both cases. These reactions are named reactions. This first one is called a Clementine reduction. The second one is called a Wolff-Tishner reduction. We're not going to go through the mechanisms for these. That's not something you have to know. Just understand what these two reagents do. The reason we have two different reagents depends on the substrate. So if you're doing a complex synthesis, certain substrates may have other functional groups that are acid sensitive, or they may have functional groups that are base sensitive. So you want to pick the best condition for the various functional groups in the molecule. For this class, you can pretty much use either set of conditions interchangeably. Now, you might be wondering, well, what's the point of this reaction when we already have the Friedel-Crafts alkylation, which will let us put an alkyl group on the ring? Well, remember with Friedel-Crafts alkylation, carbocation rearrangement can occur. So this is a good method to circumvent carbocation rearrangement. So let's say, for example, we want to put this 4-carbon chain on the ring. If you try to do that with a Friedel-Crafts alkylation, what you would try to do is use benzene, butyl chloride, and AlCl3. The problem with that is you don't get butyl benzene. Instead, because of rearrangement, you would end up with this product. This is sec-butylbenzene. That's not the desired product. So what you would do instead is start with benzene, then do the acylation. So we would use the acyl chloride with the 4-carbon chain. From there, we can now do one of our reductions. Let's just use the Clementine reduction. And that will give us the desired butylbenzene product. So this is a good method to circumvent carbocation rearrangement in Friedel-Crafts alkylations.